All right, so good evening, everybody. Sorry for the slightly late start. I was having some computer issues on this end that wasn't letting me get started right away. So welcome to the October 1st Zoom chat clinic. And my name is Patrick, if you haven't been to one of these before. And I am the program delivery partner for North Texas, and I'm also the coach of 7172 technical difficulties. Tonight, so far we don't have very many people yet in the meeting. We had about 20 sign up, but there's about 6 of you, it looks like now. And for some reason, it's placing people in the waiting room. I don't know how my Zoom setting got changed. So I kind of have to watch and see if there are people waiting in the waiting room to let them in. Before I go into other topics, I was going to open the floor to see if anybody had any quick questions or anything that they wanted to add. You can ask either by unmuting yourself and saying hello to the group and ask your question, or you can put something in the chat window. Could somebody at least put something in the chat window and let me know if you're hearing me? Normally Joe is able to join, but Joe's not able to join tonight. So no, you can't hear me. Okay, that's what I was afraid of. All right, let's see. Let me see if I can get my microphone working. Okay, some of you can hear me, so that at least tells me that, okay, good. All right. All right, well, very good. Thanks everybody for responding quickly. Richard Wang was just kidding. Way to go, Richard. You got me there. All right. I do have trouble with sometimes my microphone turns off for strange reasons whenever I switch windows, and I don't know exactly what that is. So we have a question from Larry. Can League do live in person like scrimmages apart from the tentative dates? And Larry's talking about from the Panhandle North, which is a different region. So I can't speak authoritatively for the region. The decision about how and where to hold events is left up to the individual partners. So each partner is able to decide for the venues that they have, for the conditions they happen to be under, whether they can do a live in-person traditional sort of meet or whether it needs to be done remotely. So that's up to the individual partners to decide. In North Texas, we are delaying our season until January, hoping that by delaying it, we'll be able to have more live and in-person events than remote events. But there's the options are all on the table for being able to do either in-person or remote events. That's up to the partners and to the event hosts and whatever they're able to arrange. For scrimmages, if it's an official scrimmage that is being sponsored by the delivery partner, we're prohibited by First in Texas, or we're not doing any live in-person events in the state of Texas until January. That's the current planning, and I haven't heard or seen anything that would change that. However, if a group wanted to set up their own in-person event, we can't stop you from doing it. It wouldn't be an official event, and we might discourage it, and we certainly encourage everyone to carefully consider the health considerations of the people who will be attending. We don't want a first event to be the one that is responsible for an outbreak somewhere. But for unofficial events, that's up to whoever's organizing the unofficial event and whatever they and the attendees are comfortable getting away with. But the official line is we're not doing any official competition events until after December 31st. So that's the kind of bit that's there. I have another note from Wayne who says, thank you for the Andy Mark building instructions. I'm gratified that they were helpful. And I need to go look. Actually, let me just go look real quick. I don't know if Andy Mark has made new instructions or not. I'll just switch. I'll switch windows here so that you can see. And let me just go check real quick, because if so, I would need to update my instructions. So here's the ultimate goal game set. and the assembly guide is in the guide section below, and it looks like it's still revision 1.2, which is good. Looks like there's a new version of the field setup guide from what I had before. The previous one I had was 1.1 or something like that, but the field assembly guide is still version 1.2. And so what Wayne is referencing is that I posted to the list an annotated field setup guide, which can be used and kind of give some tips and tricks about that I found and thought would be helpful to teams as they're putting their fields together. So I'm glad to hear that it was helpful. I don't have the link for that handy, but I do believe it's out on Roboplex somewhere, and it's certainly in the mailing list somewhere. Maybe I'll repost it for teams. Any other comments or questions before we begin tonight?
Hey, Patrick, just one quick question. Are we still going to have a league for North Texas, or it's all just
that's
virtual?
That's going to be up to the just a minute, let me switch back to my speaker camera. That's going to be up to the league coordinators and the teams. So I know that Guido Clymer, who was the league coordinator for the La Jolla League last year, has indicated that they're interested in running a league this year. So we just have to see how many teams would want to join that. And then a similar thing for the El Dorado League. The El Dorado League, we lost our league coordinator from that league after their league finished last year, and we haven't completely come up with a replacement for that coordinator. The requirements to have a league is we've got to have at least 12 teams or so to be able to form a league. La Jolla last year had 30 teams, so even if they lose half their teams, they would still have enough to run a league if they want to. For El Dorado, they only had about 15 or 16 teams, so they can't afford to lose too many to still be able to have a viable league. So we're still looking at doing leagues. I only got access to the team database from First Headquarters last week, and so I've got to go through and send some more messages out to teams to say, hey, this is what the plans are for the season, and let us know if you're interested in the league. But that's all I know so far.
Got it. Thanks.
You're welcome. There's a question about what was the difficult part of setting up the field based on my experience. Has anybody else set up a field? I'd like to hear somebody else's. If anybody else set up the field and if they found any difficulties or any comments they have, and then I'll add my own.
We did.
Did you have any difficulties?
I guess no difficulties, but they made a mistake about you put the horizontal piece, and then there's one side you have a drill holes. That's where you're going to attach the return. And they didn't pay attention. They put it on the other side when everything's assembled. They had to redo it.
Okay, yeah, well, I had to take a couple of them apart myself. So let me just describe what was done there. So here's the guide. Oops, I didn't change it. So here's the guide. And when you're putting in the middle pieces, so I'm just going to scroll down to where those middle pieces are, the middle panels, you do have to be aware that there are some mounting holes that you want to make sure are on the correct side. And for one of the goals that I was creating, and you can see them highlighted here. So this is page 21. When you're creating the trough, there's a set of holes that are there. And when you fold this, you want to make sure that you get the holes on the correct side. And they're on separate sides, depending on whether you're creating a trough for blue or one for red. And then when you assemble it, you need to make sure when you assemble it into the goal, you need to make sure that the panels have the holes on the correct side. So let me just scroll down here. So they pointed out here that there's two holes that have to be on the panels. And so you want to make sure that those holes are on the correct side as well. And that's because the holes that are on these panels are what are used to attach the return goals. So if you get them on the wrong side, then the return goal's on the wrong side, and it all messes up. One of the goals I was creating, I was doing late at night, I was tired, and I put it together and took it apart at least 4 times before I finally got it right. And I was getting really frustrated by the 4th time for that one goal, because I was certain I had it right, and then I was certain I had it wrong, and it took a while. So that was it. So yes, you do want to definitely pay attention to whether you're building red or blue. Any other comments? There's a comment there from Wayne that the return rack is tricky. Yes, it is. It's a really tricky part of the build. It's the most challenging part. When you folding it is okay, but when you need to tuck the tabs in, getting that to be correct and getting those tabs in is a real challenge. In my annotated version of the notes, I had a suggestion for what seemed to work with me, but you know, the corrugated plastic is pretty strong, so you can be kind of aggressive at this point, or at least I found myself being a bit more aggressive than I wanted to be about getting the tabs in, but it seemed to work out okay. For the only other challenges I had was there were parts that were missing that I found, and there were places where I had questions about what's supposed to happen here, and couldn't easily find the answer. So this is one of the classic ones. This is the one that convinced me I needed to make an annotated version. If you look at this picture, it looks like these poles are being held on with 2 screws, but in reality, they're being held on with 3. It says that in the text right up here at the top. It does say that you should secure each foot with 3 screw and nut pairs, but if you just look at the picture, you only see 2 of them there. So the first one of these I built, I only put 2 screws in, and then later I saw the note in the text and said, oh, you know, darn it. And so one of my goals somewhere has only 2 screws in it, and I'll have to find it before we use it in competition. So any other comments on building or anything like that? I'm hoping people are getting their fields and so forth. It's not a difficult build this year, which is it's kind of nice. They're not the easiest things to transport. They do take up a lot more space than in previous seasons, but I think we'll still be able to get the equipment to our events this year without too much trouble. Any other comments on anything else? No churros. There is a churro.
Yeah. Hey, Patrick, I do have another question. So you mentioned we're not going to have any kind of in-person competition until January, which is totally understandable. But are we going to have any virtual session, like virtual qualifier before that, or
not a
pretty much
qualifier.
just wait?
Yeah, I'm not planning any competition events before the first of the year. We are very likely to have virtual scrimmages.
Virtual scrimmages, okay.
Yeah, so you know, where we use for many reasons. One, because they should be relatively easy to set up, but 2, so that people can be used to the remote event format, since we've never done it before. And by people, I mean not only teams, but like volunteers, like judges and tournament hosts and partners and everybody else. But I'm not planning any actual competitions before January. And as part of that, I mean, the championship's not going to be till late March or early April for this season, so that's getting moved back. So instead of our competition season being primarily November, December, January, this year it's going to be January, February, March, and then the regional championship sometime late March, early April, and the state championship will be in May or June.
Okay, got it. Thanks.
And then the World Championship, of course, is in July. So we're being given a lot more space to be able to do it. Yeah, there is one churro this year in each of the goals for the power bar, but other than that, not too many other churros. A couple of peanut bars that are there. Any other comments? The 2 topics I thought that we would cover tonight. First of all, I wanted to just do a check-in from coaches and others and hear from you, for anybody who cares to share, just how is your team experience going so far this season? Are you able to meet? Is your team able to make any sort of progress? Are you having difficulties, you know, in communication, or is it just not working at all? Just I was going to just spend a little time opening the floor. I'm going to open the floor for others, and then I can share a little bit about what my team has been doing as part of that conversation. So, floor is open. I'd like to hear from some coaches. Just, if you're not started at all, if you're very confused about how to start, if things are working, what's going on out there? Again, you can unmute or you can put something in the channel. So Charles says they're slower because they're out of a middle school. So and that their kickoff, or I presume their starting date, will be on October 10th, and they're doing in-person meetings at volunteer houses. That sounds like a reasonable plan. One nice thing about delaying things this season, and part of the reason why I'm delaying competitions this season, is so that people can start later, and I believe it will take more time to just do all of the tasks that we're used to doing in previous years in 8 to 10 weeks. By moving things back, we're giving teams a little bit more time to work things out, and so I'm hoping that's helpful. So thanks, Charles. That's good to know. We've got quite a few middle school teams in this year, which is really nice. A lot of middle schoolers that are there, and I haven't looked this week to see what the team numbers are. Last time I looked, we were at about 80 or 90 teams in the region, but that didn't include hardly any of the Dallas ISD teams or the Allen teams. So I'm expecting to get somewhere in the range of 120 to 150 teams this year, which would make me really, really happy. We have from Leah Milton, their starting is a little bit slow, that it's been hard for them to get responses from the kids, and they're not able to meet in person yet. So they're currently in the design process. That, by the way, that's where my team is. We're still in the design process. And we also, like your team, lost a lot of veteran kids. And so we still have some veterans on our team, but they're younger. So it's, if it's a little bit slow, I think that's true for a lot of people, especially for many veteran teams. They're just discovering that it's going to be much slower this year than it's been in the past. And so that's good. Gladewater Robotics writes in and says they're having trouble getting team dynamics, and some of the remote people are not joining in with the video calls. That's a challenge. I definitely agree. I don't, many teams have different dynamics, and so for some teams, their meeting style is that you have every team member at every meeting. That has never worked for my team because our team members are in so many activities. We just accept at the outset that we're going to have meetings where a number of people won't be able to make it. And so our rule of thumb is if we can get at least 3 or 4 people together and they're being productive and moving the ball forward to on doing things, then that's good enough. We try to make sure that we don't have anybody who never makes it to a meeting, but we don't worry about everybody making it to one of our meetings. And that seems to work out fine. It also helps in our case that we try to use Discord or a messaging platform so that it's not all just in Zoom meetings. It's not all just discussion, but people writing notes to each other and putting their results into the channel so that things can into the messaging channel, so that others who aren't able to attend the time-based meetings where we're at the same time can at least catch up on some of the things and contribute that way. So team dynamics is
so Patrick,
always...
how do you solve the problem in that case when you have like a team member that's on the critical path? For example, say Matthew is building the elevator, but someone needs to build the attachment, but the elevator is not yet available. So how can that person kind of continue without getting the dependency resolved?
We in the past, and what we're doing again this year is we try not to have any component of the robot that depends on just one person. And that's especially challenging this year, of course. But we try to make sure that people are at least working in pairs, so that if somebody's not available, then somebody else can work on it. And we also just accept that there's going to be sometimes where there's blockages. So I don't have a fantastic answer for that. One of the things that we're trying this year, and it's about to go into action this weekend, is we're distributing the build process among team members. So we meet at my house, so that makes some of it partially easy. But as team members get their part of the design complete, we order the parts, and then the parts sit on my doorstep, and they come by and pick them up so they can begin building, or I'll arrange to deliver them to a team member if I have time and get the parts to them so they can start building. We don't yet know how integration is going to look, but hopefully the CAD model will be able to do that. Does that kind of answer it? Kind of some ideas at least?
Yeah, absolutely. That's really helpful.
Yeah, I mean the big thing for us is has always been in my professional life before I started doing robotics. I worked on a team project, and we had this kind of we had this concept of the bus number, which is you know it, how many people, if they got, if something happened to them and they were incapacitated, then would your project like stop? And so we try to make sure that there's always somebody available who can pick up if there's somebody not available, and we try to make sure that enough of information is spread around among the team so that so that people aren't blocked. So that's it's a challenge, but it's a good thing to really promote. It's a good thing to try, is to say, make sure that you're not depending on just one person with all the knowledge and skills, and make sure that they're spreading it around, and just make that a team goal. And if somebody resists that and says, well, I can do it better than somebody else, you can answer and say, well, but you might not be available at that particular moment, and we've got to make sure that it progresses as a team. So that really works pretty well for us. From Larry, their team has got parts, and they've started building bases. They've got their field built, and they've met 2 times after school. Larry, you're fortunate to be in an area where those in-person meetings can take place pretty well. And it's slower than usual, and they're working on CAD and programming basics. It's slower for everybody. So I think that's just part of where we are and what we're doing. But I'm glad to see that you're getting some progress, and you're at least able to meet, and we'll be looking forward to seeing your robots that are there. And Larry says they have 30 members in 4 teams, so it's like, oh my gosh. All of you coaches who run more than one team, my hat is off to you. I I can barely keep one together. So that's interesting to do. From Wayne, they're doing Zoom meetings the past few weeks. That's how my team is generally doing their meetings. And most students on the team that Wayne is coaching are electing to do academic Zoom at school, so they're kind of used to doing Zoom. And not very many members on campus, and they're using Google Classroom for their notebook. And so I think that's really good. 7172 uses Google Docs for their notebook, and so that's worked out well. We're going to have a session. It's either going to be a Saturday session or a Thursday night session sometime in the next couple of weeks, talking about the new engineering notebook criteria. If you haven't noticed yet, it's worth going and looking at Game Manual Part 1, because what you are required to bring to judging is different from the engineering notebook in the past. The Game Manual Part 1 still encourages an engineering notebook, and you should probably keep one if you're a top team. But now the key thing is the engineering portfolio, and so that's going to be an interesting challenge for teams to look at going into this year. But yes, doing the Zoom meetings, I'm glad to see that. That teams are at least able to get together and Zoom and work. And it sounds like at least most of the people writing in are doing a fair bit of CAD, which we all really expected. One of the coaches notes, read through it. It's very different for sure. It certainly is. We're fortunate on 7172 that we have a couple of people that really like working on the notebook. That's something that they have adopted and said that they will shepherd through with everybody else's help, but they really focus on it. And so at our team meeting a weekend or so ago, they asked and they said, hey, what do we need to do as far as format changes from last year, or what do we need to change? And I said, oh, well, you need to look at the engineering portfolio. And we were just meeting voice. We didn't have video, but you could hear the double take through the sound. You could just hear them going, what is an engineering portfolio? And so for those who aren't familiar with the engineering portfolio, it is what you give to the judges this year in the judging session, or what you supply to the judges, is a 15-page summary of your team's activities. So everything that used to go into your presentation and that was part of your engineering notebook now needs to be summarized in a 15-page maximum document that goes to the judges. I haven't gotten clarity on if that's 15 pages front and back for a total of 30 sheets or 30 sides of pages, or if it's 15 front and backs. But it's definitely going to mean that teams that have a lot of information to share are going to have to work hard to bring it down to 15 pages to be able to convey what they want to convey to the judges, or as Game Manual Part 1 says, to make it interesting enough that the judges then want to go and find more information in the engineering notebook. So that's something that teams will definitely be working on this year as well. Let's see. Any other comments or questions or thoughts or tips or things that people are running into that are worth knowing about? Thank you for all of you who are sharing what your experiences are. That's helpful to me in many ways as I'm talking with other coaches who are trying to figure out how to make this year work.
Oh, for the engineering portfolio, I thought I saw some conflict information. So one place I saw, as you mentioned, so they should be inspire the judge to read more on your engineering book. There's another place saying the engineering portfolio should be concise or precise or good enough, so they don't need to read your engineering book. So it's kind of a conflict, I feel.
So I think what they're actually getting at there is they want you to do both, and they want there to be, you're looking at judges, right? And so if you can present the information concise and detailed enough that the judges understand it, like let's say you're describing part of your robot and it's, you spend a page or two describing some mechanism that's really, really innovative and puts you in the running for an Innovate Award, right? If you're able to describe it so well that the judges like clearly understand how it worked and that can see the thinking behind it, then that's a really good thing. But at the same time, you may have some judges who will look at that and say, well, I'm kind of, I'm not sure about how much is in there. And so you might want to have them want to go look at the engineering notebook in that case. And so it's a tricky balance. So it's not one or the other, but it's to figure out ways that you can accommodate both those judges who are looking for a short summary to understand what your team accomplished, and as well as accommodate judges that are going to be looking for more detail and feel like they know where they can go to the engineering notebook to look for it. So it is kind of conflicting, but that's the nature of engineering in a lot of cases, is that you have conflicting needs and you have to find that balance and decide what balance is going to work best. So yeah, it'll be very interesting.
Hey, Patrick, do you know what's the driver behind? Yeah, sorry. Do you know what's the driver behind this change? Why did first introduce this new engineering portfolio concept?
Because engineering notebooks were getting too big. I think that's I don't know that for sure, but from what I've heard from people on the game design committee, that the engineering notebooks that judges were being asked to review as part of the judging process, more and more teams were bringing multiple volumes with 3 inches of paper each, and there's really no way that the judges can review that. And so they didn't get rid of the engineering notebook. You could still have it at your pit table or at your pit area, or have it available for judges when they come to interview, when the judges want more detail. But the game design committee wanted to have something that was much shorter and could be reasonably reviewed by the judges in the judging sessions in a bit more detail without having to search through things. Part of the problem is, even with the old way of doing it, teams were told to tab like 8 or so pages that they wanted judges to look at, and the judges could then go do that. But it was still hard to get a sense of continuity of the whole season based on what the teams would choose to pick. And so now effectively you get to mark or highlight 15 pages worth of stuff. And again, I don't know if that's front and back or whatever. I'm looking for a clarification on that from first. So you get to do that, but it's something where a judge could take the portfolio, flip through the 15 or so pages, and get a much better sense of the team's journey than they could if they were trying to look for individual pages in the larger set. So I think it was just reduced bulk. It was just really reduced bulk that the judges had to handle.
So is engineering book even required to qualify for the Think Award, or that's no longer?
It's not required. So the portfolio,
and it will never be submitted to the judges. Or are you saying you only submit?
You submit the portfolio to the judges, and
okay.
Right now, the judges have the right to ask for their notebook, or to go and say, do you have a notebook? And that's expected to happen not in the judging session, but in the part where the judges are going to interview teams after the judging session. So you could go and talk to a team in their pit area and say, show us your notebook. 7172 is looking at this as an opportunity to even rethink the notebook, because the notebook, now that it's not required, the formatting requirements are much less as well. So one of the things they're considering is, instead of having a single binder that has like all of their engineering notes, that they'll have separate notebooks for each component of the challenge. So they might have a notebook for, the Connect Award criteria, and a notebook for Innovate, and a notebook for Design. And that way it would help also for the judges who are coming in. If they say, we're really interested in knowing more about how you designed your robot, then you have that in an easy to use packet to be able to do that. So by separating out the engineering notebook, I think people, it's going to give teams a bit more freedom to even explore better ways of describing their journey for teams, for judges, and so forth. And not only for judges, but for other teams at the event. One of the things that I've always kind of wondered about is, when do teams ever get to see other teams' documentation efforts? You could bring a second copy of your notebook to the competition, but if you had something that was kind of more suited for specific areas of the competition, like design and things like that, I think it could be like, really useful. So I think I'm looking forward to see what happens this year.
So basically, there's no longer any requirement for the engineering notebook. The teams can use whatever format or.
Right. You're not required to have a notebook, but the top teams will all have a notebook, right? So you don't have to have a notebook, but it's almost certain that, if you have a team who's done really well and they're competing a team that's done slightly less well but has a really great notebook, I would expect the judges to kind of go with the team that provided the more documentation. And certainly, if you have two teams that are equivalent, then notebooks could be a deciding factor. So I think it's an important part of the competition that teams will continue to do. So 7172 is continuing to run a notebook the same way we've done in previous seasons. They're just considering different ways of presenting it. But at the moment, they're just continuing on as if they were making the big, gigantic notebooks that have been made in the previous seasons.
So I think it used to be a requirement to have like the engineering journal, right? Kind of the daily journal. So with the new format, I guess that's no longer required, since that's really hard, impossible to fit into 15 pages.
Yes. I would be very surprised if teams had an engineering journal, but if they a journaling, a day by day thing that they turn into the judges as part of the portfolio. I'd be surprised if there was a journal type thing, but I would, as a judge, I would look favorably on a team that has a journal in their pit and that they maintain and has a diary that can really kind of talk about their progress and things like that. It also really helps. One thing that 7172 did in the past few years is they created a separate design section for the robot and a journal section. So the journal was just the daily log of things that happened each day, either in meetings or online or however it occurred. And then the design thing was a summary of the robot design that was really focused on the design, and it would have links to the log entries, the journal entries for the individual days to say, this is, we did this on this day, and you can go read about, if you're interested in what else happened on that day, you can read about there. So try to cross-link it. But yeah, there's not a journal component that needs to go to the judges.
Got it. Thanks.
Mm-hmm. Any other comments, questions, things about putting teams together, or I'll just add, to follow up with where 7172 is at. We lost 6 seniors this last year. Collectively, those 6 seniors had about 35 or 40 years of FIRST experience that they had participated in between FRC, FLL, and FTC. And so a lot of experience left the team. We have some younger team members that we've been grooming or had been part of our team for the last couple of years that are now taking over. They're super excited for the season, and we've just been able to work pretty nicely, I think, using Discord as our primary communications medium. And one of the things that's been working for us is that our meetings have become less work sessions than they are check-in sessions. So we're currently meeting for about an hour to an hour and a half, 3 times a week. And the team members are expected to do work in between the meetings. And then at the meetings, it's milestone check-ins where we say, what were you able to accomplish? What problems have you been encountering? Show us your latest CAD model for whatever component of the robot you've designed, and let us critique it. Let us point out things where we think something might fail or might not quite work the way you want, and try and work on the design. And that's been working out well for us so far. We get good attendance at the meetings, on our things, especially because they're not so long, and it fits into kind of a homework model that many team members are already familiar with, where the time they spend in the meeting isn't to do the actual work, it's just to review the work and to make the plans for what they're going to do in the period of time to the next meeting. So that's how 7172 is working out so far. We'll as we start to get into building components, we're almost done with the drivetrain design. We're almost done with the shooter design. So we'll see how it all comes together over the next month as we start trying to pull the pieces together and let people test it and so on. So it's been a fun experience. Any other comments from coaches, rookie coaches, experienced coaches, anybody? Just how things are going? It's a new world for all of us in terms of how to make these competitions come together and how to make these team experiences come together. Okay. Well, feel free to ask questions in chat or interrupt me. The other thing thought I would cover tonight, because there was a specific question that came up last week, is to just look at using TensorFlow for detecting the starter set of rings. Normally, I would probably do like a programming session just for beginning on how to do the programming. But I haven't had time to put that together and schedule that longer session. But because the question came up last week, where somebody wanted to know how can you use TensorFlow to detect the starter stack, I thought I would walk through that exercise here tonight and show the different pieces for being able to detect how many rings there are at the beginning of the match and what sorts of things would be needed to do that. So let me, I'm gonna spotlight my own video here just to make sure that people are able to watch what's going on. So the things that I will do in this part is, first of all, I'm going to only from now on, I'm only doing control hub stuff. So for those people who are using phones as your robot controllers, I'll be glad to help if you have specific questions about it. But I'm not planning to do a lot of examples or testing on phones, because as far as I'm concerned, everybody should be using the Rev Control Hub. It's just such a better environment for stability, for reliability, for those sorts of things. Many of you will have seen the control hub, especially if you're in North Texas, you're familiar with it. But for those who aren't, this is the Rev Control Hub. It combines an expansion hub, which most people are already familiar with an Android device inside of a single unit. So the Android device already knows is already in here, already knows how to talk to the expansion hub part of this device. And as a result, you get a lot more components or a lot more ports on the back. So if you just had an expansion hub, you wouldn't have these top 5 components. You would only have this bottom place where you would connect a phone. But when you're doing a control hub, you get, oops, I didn't change the picture. When you're doing a control hub, you get these 5 extra ports. So these extra ports are, there's actually I'll turn it so we can read it. There's a USB 2.0 port, there's a USB 3 port, there's a USB-C port, there's a HDMI port, and there's a micro SD card. And those all go directly to the Android device that's inside the control hub. So you can talk to that device pretty quickly. One of the things that, of course, is very different if you're using the control hub and you no longer have a phone is most phones had an integrated camera, and teams could use the integrated camera for doing various vision things, for navigation, and for locating things on the field. But if you're using the control hub, you'll need some sort of an external camera. The camera I'm going to be using today is the one that comes in the kit. It's a Logitech C270 camera. They're fine. They work just fine for whatever you're wanting to be doing. And I have this one mounted on a tripod to make it easier for me to hold and demonstrate today. To use the camera, you'll basically just plug it into one of the USB ports. I'm just going to plug it into the USB 2.0 port. It doesn't matter which one you plug it into. The 270 is a USB 2 device, so it won't matter which port you plug it into, and be able to use that there. Now on this control hub, last week we updated the control hub so that it would have the latest version of the firmware of the operating system and of the Android and of the SDK. So you want to make sure you have at least version 6.0 of the software development kit for FTC, because it's the one that understands this year's game elements to be able to do things. Since this has an Android device in it, it also has an HDMI port, and the HDMI port is the way that you can find out what would have been on the robot controller screen when we had a phone. And so if you have a way of hooking up an HDMI monitor of some sort to the control hub, that can make things easier to see what's happening on the control hub. And I'll show that here in just a little bit. But I'm going to go ahead and just start and plug this in. I'm plugging it directly into the battery. Don't try this at home. You should use a power switch, but my desktop is getting a little bit cluttered, so I just decided to plug it in. Safety note, in case you haven't ever figured it out, don't ever plug the control hub or the expansion hub directly to the charger that you use to charge the batteries. The plugs are compatible, but the voltages are not. And so if you do that, you will burn out the control hub because the charger will send too much voltage, and you definitely don't want that to happen. For those who are new to the control hub and new to the whole control system, I'm going to run through things a little bit fast, so just kind of follow along. I want to get to the part with the TensorFlow part, but we will have a longer clinic where we focus on how to set up the control hub and how to get into the programming environment and the basics of programming sometime before mid to the 3rd week of October. So we will have some programming things on that. The other side of the equation, besides the control hub, this is what goes on your robot, is of course that you need a driver station. And so the driver station is a phone. This happens to be a Motorola E4 Play phone. It's the one that you would get if you order from the first storefront. And the phone, when you use it, knows how to communicate wirelessly with the control hub. So I'm going to set up my phone here and I'm going to set it up hopefully so that we can see the phone display as well. Um, so there's the phone display. It's just an Android smartphone. And of course, the application that you need to install on the phone, which the new Rev hardware config software will even install software for you on the phone. So you want to make sure you have the FTC driver station software. So I'll just run it. And just a minute while it makes all of its noises here. The driver station then connects through Wi-Fi to the control hub. The Android device in the control hub acts like a Wi-Fi hotspot. And so you can then have the driver station connect directly to the control hub through that Wi-Fi hotspot, and they're talking to each other directly. You don't need any other network, any other Wi-Fi hotspots, any other support to be able to do it. As I often say, you could take your driver station and your control hub to the bottom of the Grand Canyon where there's no internet access, although there probably is at the bottom of the Grand Canyon these days. But you could take it somewhere where there's no internet access and you would still be able to run your robot because they're able to communicate with each other directly. So once you have the control hub powered up and you have the camera put in and you have the driver station in place, one of the first things that you will need to do is to create a configuration. Inside of the control hub, there's always a part called the robot configuration. So all I did to get to that, let me get my contrast here correct so that hopefully people can read this somewhat. There we go. So in order to get that, it used to be that you could set up the configuration from the robot controller. Since there's not a keyboard or display on the control hub, you now do it from the driver station. That's the easier place to do it. And so I just go to the three dots that are up in the upper right-hand corner and click that, and that brings up this menu. And then I can go to configure robot, and that brings us to where we can create a configuration. I'm going to create a new one, in this case, from scratch, that will attach in the web camera that I have. So I'm just going to say new, and that creates a new configuration. And for those who are used to working with the expansion hub, the thing to note is that you now have this thing called the control hub portal. That's good, but your webcam is a separate USB device. And so because it's a separate USB device, it appears here. And you can rename it if you wish to something else, especially if you have multiple webcams, then you can rename it to a different name that you'll refer to. But you want to make sure that you have the webcam in the configuration. If you start up the control hub and the webcam is not already plugged in, then you won't see the webcam show up in the configuration. You obviously won't be able to use it in your program. So all I did was go and say, create a new configuration. If I go into the control hub portal, this is where I can go and add motors and servos and all of the things that we used to do to configure those. But the webcam exists outside of the control hub portal because it's another USB device. So I'm just going to save that. And I'm going to give this a name. I'm going to call it, well, I'll just call it TF demo and let it overwrite. I have some other configurations on here that are from other robots that I've built, but I just want to do TF demo, stands for TensorFlow demo. So I'm going to activate that one and I'll return to the main screen, and it will now come up and show the control hub and connect with the control hub with that configuration. All right, so in order to be able to use the webcam on the control hub, you just plug it into a USB port and then you go stick it in the configuration and you keep track of what it's named. So now that we've done that, I'm going to go and connect into OnBot Java to show how we actually do the programming of it, or how to find out how to begin programming to detect the number of rings that are on the field. So just a minute, I'm going to go back to Zoom and share my screen. I like doing this by share screen instead of through my video camera, just because it's a sharper image for you guys. All right, so on my computer, what I've done, now I'm running Linux, I'm not running Windows, but it's a very similar process. Actually, let me go share a different screen real quick. Let's share screen and see if I can share the whole desktop. Let's share desktop one. Okay, and so on my computer, I'm running Linux, and so this is where I do the connections for Wi-Fi is right there. Can you all see the network window in the bottom right that I just clicked up? Because I can't see what you're seeing necessarily. Um, we'll see if yes, I got a check mark there, so it looks like yes, good. So on my computer, in addition to my wired Ethernet connection, I added a Wi-Fi dongle. It's a little Wi-Fi device. I have another one here that I can probably show. Is it this one? No. Anyway, it looks like a little flash drive, but it's just another wireless interface. And that allows me to have my computer be connected to the internet at the same time as it's connected to the control hub. So again, because the control hub is a hotspot, you can just, it's an access point, you can just connect to it directly. So I've gone ahead and done that. And once you're connected, then the address to get access to the control hub is 192.168.43.1:8080. And that information is in the instructions for how to connect to the control hub. So I'm going to go ahead and do that real quick. So let me go to that page. And actually, I'm going to, yeah. So now I'm connected to the control hub from my browser on my desktop. And here you have a number of different options available for how to program it and how to manage it. So if I just go to the manage menu, somebody please interrupt me if you're not seeing this the way I think that it's going out. But from the manage menu, you can see what robot controller version you have, the control hub operating system version you have, the firmware version you have, and so forth, and various other Wi-Fi settings and things like that. I'm going to go into OnBot Java, and I promise the font will get bigger when I do that. So I'm going to go into OnBot Java. I want to switch the way I'm sharing my screen here. So let's try it this way and see if you're able to see that. All right, and so just a real check, just as a check, you know, are people able to see the OnBot Java code editor that I have brought up? I think I'm sharing everything, and I see another check mark in. Yes, okay, great. All right, so again, I'm going to focus on TensorFlow, but the general interface for doing OnBot Java, and here you're doing your programming on the control hub, and that's a really nice feature. Is that the programming is done on the control hub. So the only software that you need to have is a browser. You don't need to install anything else on your computer other than a browser. Google Chrome is what is recommended. So right now I'm talking to the control hub directly. If somebody pulls power from the control hub, if somebody turns my robot off while I'm in the middle of programming it, I might lose whatever latest changes I had and not want to do that. On the left is the project portion of the programming interface. These are all of the programs that your team will have created for the robot, and we're going to create one here in a second to do TensorFlow. In the middle is the main canvas where most of your programming takes place. In the bottom is the build window, which is where we build our programs and see what sort of errors or things might be in our programs. And the last major piece is this little wrench that's over here on the side where you actually tell the program to build and be ready to run. So to get to the TensorFlow part, if you want to create a new program in OnBot Java, you generally start with this add file operation. It's the little plus sign that's over on the left. And so if I click that, then I get this dialog box where I'm going to put in the information about how to create the program that I want. So for my file name, I'm going to call this just a TF demo. That stands for TensorFlow demo. And I should talk about what TensorFlow is here in a second, but let me go ahead and finish this step out. So I'm going to create something called TensorFlow demo or TF demo. Its location is going to be in the team code. You can just leave that as default. And then I can use one of the sample templates that has been pre-built for me by the First Tech Challenge team. There's a lot of templates that are already here. The main ones that you typically use are either a basic op mode or a blank op mode. Op modes are the different modes that your robot can be in. Typically, you'll have one or two modes or multiple modes for your autonomous portions that you want your robot to do during the autonomous session. And then another op mode that is your driver controlled op mode. So your team can put the robot into different modes depending on whether it's red or blue, whether it's starting in the left or in the center, whether it's configured, what your partner is going to do. You can have different op modes for each of those. A number of the op modes are called concept, and these are meant as demonstration op modes for your programmers to look at to get an idea of how to use a sensor or how to use a specific capability on the robot. And the one I'm going to focus on is this one called Concept TensorFlow Object Detection Webcam. And so that is that and that's not actually showing up on my output screen. So let me click on it. So Concept TensorFlow Object Detection Webcam. There's a number of others that are available, including object detection without the word webcam, in which case it plans to use a phone camera for detecting. And there's also one where you have switchable cameras. So if you have multiple cameras on your robot, then you can say which one that you want to have. And there's an example for that. But I'm just going to do the webcam example. I'm going to say that it's going to be done in teleop for this, so it'll run for a little while. And I'll say, okay. And it will then bring up this software, which has a whole lot of comments at the beginning that we'll look at in a second. But this is a program already rewritten to be able to demonstrate how TensorFlow works for detecting rings and how you might use it in your own program. I'm going to hide this little section at the left because we don't need it anymore. And this is the actual programming code. Again, at some point later, we'll go through more of the details of how the programming works. But I'm going to point out some of the key things to kind of show how it comes together. Any questions real quick before I go on? Anything that somebody would like me to cover or really is confused on or anything like that? There's a question about the Amazon link for the Wi-Fi dongle. There are multiple dongles available. My recommendation is to be sure to get one that is dual band, that can work with both 5 gigahertz and 2.4 gigahertz. So if you make sure to get a dual band dongle, then you'll be able to talk to your control hub in the 5 gigahertz band, which is the better place to be over the old style 2.4 gigahertz band. So definitely go for a dual band dongle. I have one that is in the hardware guide that I recommended before I bought it, and then I decided I don't like it because for me, I have to install special drivers. So I'm looking for other Wi-Fi dongles that I want to use to replace that. If you go to roboplex.org, let me go back to the Roboplex or to the screen. If you go to roboplex.org, there is a page on Roboplex on the FTC section called Hardware Tools and Tips. And so you can follow that. And then from there, there's a link to the current hardware guide. And so if you follow the link to the hardware guide, the hardware guide has a lot of suggestions for different parts, including a Wi-Fi dongle. So there's a couple of Amazon links here for Wi-Fi dongles that are suggested ones to look at. The one I got that I didn't like so much, I think, is the first one of these. I'll try and get that updated this weekend. I'm sure it would work fine on a Windows machine. Since I'm not using Windows, it wasn't nearly as helpful for me. All right, so back to the code. So for Vuforia, I think one of the things to know or to be aware of for Vuforia is we hear about these two different components of the image processing session. One of them is called Vuforia and the other one's called TensorFlow. And so I know a lot of people will often be confused about what is Vuforia, what's TensorFlow, you know, what do the two of them do? So Vuforia is a piece of software that is included in the FTC software development kit that you download and put onto your robot controller. And it knows how to talk to the camera. It has all the software and the drivers needed to be able to talk to a webcam or to an onboard phone camera. So Vuforia is the software that controls the camera. It also has intelligence in it or programming in it that it can understand the targets that go on the game perimeter walls. So around the walls of the field, there are these pictures that go in specific locations around the field. And Vuforia is able to look at those pictures and figure out and triangulate where it thinks your robot is on the field. So some people have been able to use that for navigation. Some people are able to use that for targeting and so on. So that's what the Vuforia software is. It's the part that knows those pictures that go on the perimeter walls, how to use those and how to navigate your robot relative to those. TensorFlow is the other part that is also included with the software development kit. And what it does is it's able to recognize objects. It's able to look for specific objects in different configurations on the field. So in previous years, it was able to find the cubes and the balls that were used in Rover Ruckus, or it was able to find the stones, the bricks that were used in Skystone last year. This year, it's been trained to be able to recognize the rings. And so we're going to walk through what that looks like and kind of show how easy it is to get the demo up and running and to use it to identify rings. But every season, TensorFlow comes with a set of training modules for the game pieces used in that particular season. Now, because TensorFlow needs a camera image, what they do is they grab the camera image from Vuforia. So in order to use TensorFlow to identify the rings, you first have to be able to set up Vuforia. So I'm going to walk through that here for a bit. And if you just follow the code, you can ignore most of the comments at the beginning. All of this text that's in green, I don't know if you'll be able to see that it's in green, but with the asterisks in front, those are all comments, which means they're in the program code, but they don't affect what the program does. And that's where you can put notes and copyright notices and all of this bit that's here at the beginning. The first bit of comments are really long and you can kind of ignore them. But once we get into the programming code, these comments become really important. So this first part here that starts at line 42 says, this 2020 to 2021 op mode illustrates the basics of using the TensorFlow object detection API to determine the position of the ultimate goal game elements. What that's saying in English is TensorFlow tells you how many rings there are on the field at the beginning of the match. So use Android Studio to copy this class or use it in your program. Important, in order to use this op mode, you need to obtain your own Vuforia license key as explained below. So before you can use Vuforia, before you can use the camera from this software, then you need to get a license key from Vuforia. And so let's just skip down to the next section here. And in the next section, it says, important, you need to use your obtain your own license key. The string below won't work. And a Vuforia development license key can be obtained free from the Vuforia development website at this link. So I'm just going to copy this link there. And I'm going to open up a new Google Chrome tab. And I'm going to paste that link into the address bar and go to that particular link. And when I get there, it says create a license key for your application. I have to log in to be able to manage those keys. I already have a login at Vuforia, so I'm just going to do it. If you don't have one, then you can create an account. It doesn't cost anything. So I'm going to log in. Please don't look at my password as I'm typing it in because I typed it in wrong anyway. All right, so I'm just going to log in. And so when I log in, here's the key I created earlier. If you don't already have a key, then you can just say get development key, and that will allow you to create a brand new key. Again, it doesn't cost anything for the development key. You can safely ignore this part that says buy deployment key. You just need a development key for FTC. And so I'm going to go to this key that I created, and when we pull it up, it's going to go through. The key that gets created is this big long string of 300 plus characters that look like random gibberish in this gray box. That is your license key. And so every team should have a license key. It's okay for every student or developer to have their own license key. So that needs to be copied into the OnBot Java code or into your Java program to enable Vuforia to work. So I just click on this gray box. And when I do that, you'll see a little note shows up on the right that says it's been copied to my clipboard, which is good. And now I'll switch back to the Java code that I was hit at, and where it says your new Vuforia key goes here, I'm just going to highlight that text, and then I'm going to hit Control V on my keyboard and paste in the key that I copied onto the clipboard into that text. And you can see it's 300 characters long of data. So I'm just going to scroll back over to the other side, but now my key has been set up, right? And so now with that key set up, I should be able to access the camera that is on my that's on my control hub. The next step, that's it. For using this demo program, that's all I really need to do. The next thing I need to look at, though, is I need to go through, and there's comments that explain what all of the variables are doing, so your programmers will be able to go through and start to figure out how it works. And we'll cover it in more detail in a future clinic, certainly if anybody asks about it. But the code is all here to be able to use TensorFlow to do it. The other thing that we need to double check is that, did I copy the wrong one? No, webcam, is that the webcam identifier is the name of your webcam. Where is my webcam identifier here? I'm not seeing it. It's not there. It's not there. Vuforia, that in it, Vuforia. Okay, I'm gonna have to do a search here and see if I can find it. Oh, I can't find it that way. Concerned that my, oh, here it is. It's down here. Sorry about that. If you just took the defaults for Vuforia and when you set it up in the hardware configuration, and again, the hardware configuration is this part that's over here. So on my camera, I'm going to go back into configure robot, and I'm going to go look and edit the configuration I created. What you want to make sure happens is that the name that is in this line, webcam 1, matches the name of your camera in the configuration. If those don't match, then it won't be able to find the camera. So by default, when you configure a camera in the configuration, it's going to be called webcam 1. Inside of the program, it also needs to be called webcam 1 with a capital W. So as long as those two things match, then everything should work from this point. So once that's been done, I can build the software. And so I just hit the little wrench icon, and it will say building the software. If any errors were introduced, they would show up down here in this bottom window. My window says build successful, which is what I really want to see. And that means that the program, the op mode that I just created for doing this TensorFlow detection, is now available on my control hub. So I'm going to switch over to the control hub here. Right, so that software that I just created, that program, has now been loaded onto the control hub, and I can access it from my driver station. So it's currently resetting or reset, or yeah. Let me oh, there it is. So because I had said that I wanted this op mode to be a teleop op mode instead of autonomous, it's going to show up under the teleop menu, which is this menu on the right. I know the writing is really, really small, but what this is saying is autonomous on the left. And so on this left arrow are all of the autonomous programs that you've created. I haven't created any. On this arrow on the right is all of the teleop op modes that have been created. And here's the one that was created that is the concept TensorFlow object webcam 1. So I'm going to select that op mode. And when I do init, then it will start that op mode running and then begin running the robot. For those of you who may be new to FTC, the driver station, when you want your robot to do something, you select an op mode, you select init. Normally, that's where your program sits until they say 3, 2, 1, go. When they say 3, 2, 1, go, you'll hit play, and that'll start your robot working. I'm going to segue for a second here to show what's happening on the control hub itself. So on the control hub, there is a port for an HDMI connector, and I'm going to go ahead and plug in this HDMI port into my onto my system here, so that we can see what's happening on the control hub. And in fact, what I think I'll do real quick is I'm going to reboot the control hub. So to reboot the control hub, I'm going to just pull power My program has been stored on the control hub, so I'm pretty safe that that's going to happen. When I pulled power, by the way, my driver station phone noted that it disconnected. So it says it's not able to talk to the control hub right now. So that's happened. And I'm going to turn on the control hub, and I'm going to switch to the HDMI output from the control hub so we can see what's happening there. So this is the output of the control hub right now. So Rockchip kernel, and it's now booting into Android because the control hub is running Android, and it's now pulling up the screen. And what we will see is this is what, if you were using a robot controller phone, it's a lot like what you would expect to see on the robot controller phone. So this is, just a minute while I get past the sound here. So this is the robot controller. And the way that you can tell it's the robot controller is because it says 1304-RC up at the top. So it's not the driver station. We're not looking at the driver station phone. Here we're looking at the output of the robot controller. If I had a keyboard and mouse, excuse me, hooked up to the control hub, then I would be able to actually interact with this display through that keyboard and mouse. I don't have a keyboard and mouse, so all I can do is see what's on the display. But I want to show what happens now. You can see the control hub came back up. The driver station and the control hub were able to connect with each other. So I'm going to go and I'm going to say, let's do TensorFlow. So I've selected the TensorFlow object detection op mode, and I'm going to hit the init button. And when I hit the init button, that enables the webcam. And so on the HDMI display, there is the webcam that I have sitting over here running things. And I'm going to turn off the driver station real quick. And it is currently aimed at a stack of 4 disks. And you can see that it says, I see 4 disks, right now. And if I take the disks away, if I take and do 1, then it says, I see 1 disk. And you can kind of see that in the type of thing that it's looking at. If I take away that disk, then it's going to say, I'm not seeing anything. So as long as the camera is there, if it sees 1 disk in the view, then it knows, aha, I'm looking at 1 disk. If you look at the bottom left, it'll say single. And that's how it knows that it's looking at 1 disk. If I have a stack of 4 disks there, right, then it'll come back and it'll say, oh, I'm looking at a quad. I'm looking at 4 disks that are there. And that's how it's able to pretty quickly identify how many disks are in the starting spot. So you'll either have 0 where it's not seeing anything, or you'll have 4, in which case it says, I'm seeing a stack of 4 disks, or you'll have 1 at the beginning of the match and it will see only 1. So it's already set up to tell us that. So let's see what's happening on the driver station right now. And we'll go back and look at the code a little bit as well. On the driver station, I hit init, and so init starts the camera running on the control hub, and it starts, TensorFlow is running and it's recognizing the disks. But I haven't hit play, so my robot's not doing anything with that yet. I'm going to go ahead and hit play on the driver station. And now the program has been set up. I might need to make it a little brighter if I can. Let's see if I can make it brighter. Come on, camera, work with me. Oh, I'm not able to make it brighter. It doesn't seem. But down at the bottom, this is the program saying what the camera is detecting. Because when you're running, you only have the you only have the driver station. You typically have a monitor on your robot to be able to see what's happening in that other window. So in the background window there, I'm gonna like pretend it's not there, because normally what we would be looking at is just the driver station. So here we're going to look at the driver station and see what it's seeing. And so right now the program knows that it's looking at 4 disks. And if I go back to looking at the which one was it? If I go back to looking at the camera view, wrong one, there, camera view, there are 4 disks there. If there's 1 disk available, then you can see that the display on the driver station is changing to say, aha, there's a single disk. And if I don't have any disks in view, then it comes back and it says, I'm not seeing any objects. So it's already really kind of built in to do that. What do you do if you don't have a HDMI monitor on your control hub? So if I don't have my control hub, it's on the robot. It's kind of inconvenient to hook it up to an HDMI monitor while you're actually doing things with the robot. So how can I see what the camera is looking at in that case? So I'm going to stop everything here, and I'm going to pretend I don't have the control hub signal anymore. So I'm just going to switch to the overhead display, right? And I'm going to even unplug my I'm going to unplug my HDMI controller. So here we have the control hub there, but I don't have HDMI output. So how can I see what the camera is actually seeing? So on the driver station, I'll just hit init. And when I hit init, we know that the camera is actually running. It's actually putting that image out there. And I'd like to be able to see it. On the driver station side, there's now an option available where I can hit the three dots. And with the three dots, I can hit the three dots in the upper corner. And there's an option here for camera stream. You can only see the camera stream while you're in init. Once you hit play, the camera stream's not available. So I'll hit camera stream, and it pulls up a still shot of what the camera, of what the webcam saw at that particular moment. It's not a live stream because sending a live stream would take up too much bandwidth for transmitting video over Wi-Fi. So it just sends a single picture image of what the camera was looking at the time that I opened the camera stream. If I do a refresh, I can just click the picture and it'll give me another stream. So I'm going to put something else in front of my camera now and click the little button, and you'll see that now it sees that there's something there. And I'll take it away. And even though I've taken it away and got it not in front of the camera, once I click the image again, then I can say, give me an updated image, and it gives me an updated image and tries to figure out what's there. So if I put a ring in front of the camera and tap a ring, then it says, aha, I found a ring. And let me move it a little bit farther away and tap it again. And it knows that it found a single ring. So from the driver station, the part that you have that's your remote control of the robot, you can get, while you're in init, an idea of what the camera is seeing from the robot before you hit play, and to make sure that your camera's lined up on where the rings are going to be. When a match is taking place, what happens is you set up your robot, you get it all the way to the init section when you press init, and then at this point you're waiting for it to be 3, 2, 1, go. At this point, the referees will randomly change the number of discs that are in front of your robot, but you know that your camera is going to be pointed at them. And then when you hit play, that's when your robot would have to determine how many discs are there and figure out what it's going to do in response. So let's just do that real quick. I'm going to pretend, we're going to pretend we're the robot, so you don't know how many discs I've put out there because you can't see the camera or whatever. But I've actually just put 4 discs there. And once I hit play, you'll see that the program has come up and it's able to say, aha, I detect a quad. There are 4 discs there. And now the robot would know what it needs to do, or can know what it needs to do because there were 4 discs there. I'm going to randomize it up again. And this time we'll put only 1 disc there, and I'll hit play, and it'll come back and it'll say, aha, I found a single disc. So what's happening in the code to make that happen? And then I'll take more questions. So what's happening in the code to make that happen is, if we go through and look at the program code, when you're running a linear op mode, there's this special function called a run op mode, and that's where everything happens. The real work is happening here inside of this loop. So we stay inside of this loop, and inside of this loop, these are the lines of code, which again, I'll go through in more detail, but this is where to look. These are the lines of code that describe what TensorFlow is seeing. So we get a list of the things that TensorFlow sees, and we find out how many of those it sees and report that. So if TensorFlow says, I don't see anything, then you know that there are 0 disks in front of the robot. If it comes back and it says, I see something, then you would go and ask, what is it I'm seeing? And based on the label you would get either the word single or the word quad. If you get the word single back, then that means you're seeing 1 disk. If you get quad back, you're seeing 4 of them. And then based on what you see there, now your robot can go and decide what mode or what it's going to do in autonomous. So you could then test for what kind of thing are you seeing and decide how your robot should behave as a result. So that's the very beginning of using TensorFlow for doing the object detection, things that are happening. It's really simple to use the demo program. Get that set up. That's the first step for figuring out how to use TensorFlow, and then you can go through and look at the code, kind of see how what the code is doing is changing what's happening on the driver station display. You can see through the camera stream what the camera is actually seeing, and begin to build your autonomous mode from there. But the tricky part of figuring out how many disks are there, TensorFlow seems to have taken care of pretty well. All right, that was a long segment where I didn't take questions, so I will go and do questions. I have one question. Would I prefer TensorFlow over OpenCV that's used in Android Studio? TensorFlow is easier to, if you don't know OpenCV, there's a bit of integration work that you have to do OpenCV. So TensorFlow is a fast and easy way to do it. It seems to be pretty robust. And for this year's game, I would think TensorFlow is probably enough. It's the last year's game, TensorFlow was a bit of a challenge because what was happening for TensorFlow in last year's game is you had to try and pick out the blocks that had black stickers on them in a line of yellow blocks. And so TensorFlow, because the blocks were all next to each other, often couldn't tell whether it was seeing one block or two next to each other. And so it would often get confused by that. This year, I don't know that there's a lot of room for TensorFlow to get confused. However, I did find one place where it obviously does get confused. So let me just show that example here real quick. I'm going to go back to showing the HDMI video because it's easier to see there. So let me pull up the HDMI video like so. And so right now it says it's seeing a single disk. That's good. And if I put a stack of 4 of them up there, then it says I'm seeing a quad. That's good. But if I put the camera low to the ground where it's even with the rings, it thinks that's earlier when I was doing it, it was thinking that was a single. Right now it's still thinking it's a quad. So that's pretty good. But earlier when I did that, it saw that as being a single. It might be because the lighting has changed inside of my office here since I did that. So that was one place where if the camera was too low, it was having trouble distinguishing 1 versus 4 from a really low camera angle. But from up higher, it was not having any trouble at all. And that's where I would expect a camera to be on a robot as well anyway. I would think that with OpenCV, you can get a lot more. OpenCV is a library. It stands for Open Computer Vision. And with OpenCV, you can get a lot more control over the image processing, but that does take a lot more work. If you're planning to do other things with vision processing beyond just figuring out how many rings there are at the beginning of the match, then it might be worth using OpenCV for that and just skipping TensorFlow entirely. But TensorFlow is there. It's in the software. It's part of the software whether you use it or not. So it's a good thing to check out. One thing that might be good to consider also is instead of saying TensorFlow or OpenCV is to use TensorFlow and OpenCV. And that's actually what 7172 did last year to get around the problems with TensorFlow. They did TensorFlow to identify where the stones were likely to be in the image. And then they did their own image processing, not with OpenCV, to figure out where the sky stones, the ones marked with the black sticker, were. And that became super reliable in all sorts of lighting conditions. So they didn't rely on TensorFlow entirely. They used TensorFlow to get it started. And then the results of TensorFlow, they could do their own image processing to find out where the sky stones were very, very quickly and accurately and reliably. Another question that's in the chat is for pictures, is it best to print on plain paper or photo paper for Vuforia? On the competition fields, it'll be cardstock. So not reflective paper. So I wouldn't use a glossy photo paper for that because the instructions actually say to use cardstock. I suppose photo paper could count as cardstock. But I don't know that I've seen that the type of paper used is all that big a difference. I'm pretty surprised that Vuforia works as well as it does, to be honest, because the pictures are inside of paper protector sleeves behind some polycarbonate polycarbonate walls, and somehow Vuforia is still able to pick up the images. So I don't know that the paper type makes that big a difference. What I've been using is just 110 pound or 65 pounds, just some heavy paper, some good cardstock paper, and printing on that with my inkjet printer. And so that seems to work pretty well. There's a question that says, what results do you see if there are 2 rings or 3 rings placed? Which I'm glad the question came up because I was curious about that as well. So if there are 2 rings placed, right now it's thinking that's a single ring for me on this camera. Earlier when I tried it with slightly different lighting conditions, it thought it was 4. I thought it was a stack of 4, but it looks at that and its algorithm says, I think that's a single. One of the things to note, that big number that's up at the top, that's the confidence that it has in what it's seeing. So right now it thinks that it's 1 ring, but it's only 82% sure that that's what it's seeing. If I take one of the rings out, you'll see that number goes up to 96. So now it's 96% sure that it's seeing a single ring. If I put another one on there, it says, well, it's single, but I'm only kind of certain to 82% confidence interval. If I put a third one on there, now it says, I think it's a quad, and it thinks it's pretty certain about it being a quad with 4 disks, even though there's only 3. And if I put the fourth one on there, then it says, now I'm 98, 99% sure this is a quad. So those numbers that are there on the top, that is the confidence interval. And you can change TensorFlow to say only report things that are above a certain confidence interval. I think by default it's set to like 80%, so it won't report anything that it's not 80% sure of. But you can tune that downward or upward to say, I only want to know about things that you're 95% sure about, or that you can say, I'm interested in anything, even if you're only 50% sure, let's go with that. So just to repeat, so 4 rings, it's seeing and saying, I'm pretty sure about that with 99% interval. With 3 rings, it's less certain. With 2 rings, it's looking at it and says, I think that's a single, but I'm only about 90% sure about that. And with 1 ring, it looks at it and says, I'm 96% sure about that. So really good question. Any other questions? Any other things people want to know about? I know it's a quick intro. And when we do one of our longer 2 or 3 hour sessions, we'll walk through the programming in much more detail. But to just get started, to recap, the things to do to get started are, let's go back to Chrome here, and I'll turn off the display there. So, oops. So to get started, go into OnBot Java. There's a blocks version of this too. If you want to do it in blocks, I tend to recommend OnBot Java for most people. Go there. You have to pick a name for your program. So this will be tfdemo2.java. File names have to begin with a capital letter and only contain letters and numbers. In the sample screen, you can go pick a sample. Oops, I'm not broadcasting that for some reason. Just a minute. There. So in the sample screen, there's a bunch of samples that are being listed on my screen in a pop-up that you can't see, but you want to pick the one that's Concept TensorFlow Object Detection Webcam. And choose that. You want to say whether you want it to show in the teleop menu or the autonomous menu. And then if you hit OK, it pulls up this set of code, and just follow the instructions in there to figure out how to get your Vuforia key, paste it in, make sure the webcam is on the right thing, and then run it. And that gives you a really nice, not a very long program. It's only 160, 70 lines long, and many of those are comments. It's not very long, but that's where your programmers can start to go through and kind of figure out the steps that they need to do something similar. Can you stream the control hub screen to the computer using Smart View cast option in Android? I don't know if there's a way to get to the cast option in Android. I would think that it would probably work. I wouldn't suggest doing that at a competition venue because it'll eat up a ton of network bandwidth and you might get caught by the network police. Certainly in your practice environment, wherever your practice ring is, you could see about maybe doing it through Google Chrome, through a cast option. I haven't tried that yet. It's a really interesting question. So I may play a little bit because I have a Chromecast device here at my house, and so I can see if I can cast the screen to that. That would be really useful if it works. Great question. Thanks for bringing that up. Any other questions from anybody? I have another question. Is the Intel RealSense 265, is it legal for FTC? I don't know if the question has been asked in the Q&A forum yet. When I checked yesterday, it had not been answered. So the T265 is a tracking camera that we're looking at for possibly doing tracking. Here's the actual camera. You can see it's not very big at all. It's able to do positioning and sensing and things like that. There's not been an official ruling from FTC yet on that, but they probably haven't started answering many Q&A questions yet anyway. They opened the Q&A forum just a week ago today, and typically they wait a week or two before they start answering questions, just so that they can get them all kind of settled down and get an idea of how they're going to be answering them. And so I don't even know if anybody's asked the question on the forum yet, and I haven't put it in for 7172 yet because I'm waiting to see if it's already asked or not. So we don't know about the 265 if it's going to be legal this year or not. There's a comment that Windows 10 has Connect that can do the same thing as Chromecast, so that might also be a way to look at doing things as well. So I would consider that. Any other comments or questions? Is there a way that you can change the code for TensorFlow into an if-else statement? Yeah, I can do something like that quickly as an example. I think I can try doing it. So let me switch back to Chrome here. So what happens is it's in this loop that's here, and we're doing the recognition. And what I'm going to do is say if the thing that I got is a quad, I'm just going to set a variable to be able to do things. It's a little bit challenging with the way this code is set up, but basically I'm going to look and say, give me a string, and actually let's make it bigger. Let me get rid of that line. And again, if you don't know the Java code yet, we'll cover it in more detail in a future session. But just very quickly, I'm going to say string rings equals none, like so. And I'm not going to worry about the none case, but I'm going to worry about I'm going to cover the case where we see a ring or we don't see a ring. So here I'm going to say rings equals recognition dot get label, and I'm going to do a break. And what this break is going to do is it's going to break out of this loop. Actually, I need to break out of two loops there. So let's change. So I'm going to do a break. So that's going to break out of this loop. And then above that, in this one, I'm going to say, while op mode is active and rings dot equals, nope, what's the thing? Is equal? Nope, I forget how to do equals in strings here. I think it's this. Yeah, equal. Thank you. None. So as long as we haven't seen a ring, then rings will be equal to none. So we'll stay inside of this loop. Once we get a ring that's, in fact, I don't even need the break anymore. I can just get rid of the break altogether. As soon as we see something that see a ring or a stack of 4 rings, we're going to get there. And now, once we're out of this loop, out of this while op mode is active loop, I can do an if then statement at this point, and I can say if op mode is active, like so, and I can just output. I can say if rings equals quad, then we're going to do something, then we would have the robot should behave for 4 rings. And that would be a whole block probably. So I'll just make it a block to make it clearer that that's what should happen here, right? There. So if rings equals quad, then we'll do that. Otherwise, if rings equals single, then the robot should behave for a single ring, right? So you can break it down into an if then else statement pretty quickly there. The idea is that you kind of stay in the loop until you figure out how many rings there are. And then once you figure out how many rings there are, you can break out of that loop. And now you can do an if then statement to do one set of things if you saw 4 rings, otherwise do another thing if you saw just a single ring. And you don't have to do the strings as I did it here. You could check for the strings quad and single here and set a number. There's all sorts of different ways that you could look at doing that. But again, you kind of stay in this loop until you see rings or until you are comfortable with what you want to do. And then once you have seen some rings, or once you've decided what you've seen is the result, then you break out of it, and then you can choose which one you want to do on this one. What 7172 did last year is to while they were in init mode, they were looking constantly at the field and updating what they were seeing on the field, so that by the time they pressed play, the robot already knew what the latest state of the field was with respect to how many stones or where the stones were placed. And I imagine that they'll do the same thing this year, where they'll have TensorFlow running while they're in the init state before they hit play, constantly looking to see how many rings it has and setting a variable. And then when they hit play, that variable will already have what the state of the field is, and it can instantly start running into its next thing. And again, I'll show some code examples for doing that in a future session. Any other questions? All right. Well, for those of you who hung around, thanks a lot. I'm good for tonight. It's about 20 minutes to 9, and that's good enough time. We will be doing some more sessions on OnBot Java programming here in the very near future, and showing some more detailed examples of how to do rings and things like that. So watch the mailing list for announcements of that. We've been posting the videos as quick as I can get them, and I've been trying to not have to do any video editing to the YouTube channel, so you can go to the YouTube playlist and find the latest videos. I'm glad that this was helpful, and that I hope you enjoyed it and that it was useful. Share it with your teams. Thank you to everybody who suggested or sent let us know how your teams are going so far in the season. That's really useful information for me as a partner, and to be able to convey to others that are higher up. And have a good night and a good weekend, and we'll see you again next week. Take it easy.
Thank you.